Hi guys, welcome to my YouTube channel, and in today's video we will be discussing about database sharding. We'll do a deep dive into it, so let's quickly begin. And just a news, I have started writing my newsletters, and you can find my newsletter on suchet.substack.com, where every video that I'm presenting you will find the same newsletter for that particular video. You can go over it, understand in depth, so that's kind of a document for that particular video lecture. I'll mention the link in the comment section or in the YouTube description section. So in today's video, we will be discussing about database sharding, as I said, right? So this database sharding, before understanding the database sharding, first understand what is that particular problem that your database sharding solves, right? So now the problem is, let's say, the problem is, just look at this big DB. This is the beautiful diagram that I have created, right? So you have a big database, or let's say it's a cluster of database running somewhere. And then all the clients, in each of my system design videos, I keep on saying clients. I actually mean the application which is consuming your API, your data from your application server. So let's say your application is being used worldwide, or let's say you are operating in 3 major countries and your application is being consumed by 3 geographical locations. Now your queries, all your queries coming to one of the country where your database server resides in, right? So your queries could have a latency in it, right? Because your server is far in the distance where your client, your application is making the request from. Now in those certain, so this is one of the use case, right? You see, your query performance will be very slow. In this particular case, your query performance will be very bad because you see your server is very far away, right? And also understand the fact that, let's say, you have a very large database, right? You have a very large database, and then because you have the big machines, your one dedicated server, it could be a cluster of machines, but still you could end up having a lot of records in it, right? So let's say this country one application is trying to consume your application. It has to traverse or basically process a lot of records, although it doesn't need that much records, right? There's one condition, because in this single database approach, that's a limitations of space. Or let's say you are using a lot of a single database, and then there will be a problem of scaling, right? You cannot keep on scale it well. Let's say if you are using cluster, although you can add on more machines into it, but it again, when you are adding machine into it, right, you are adding infra into it, and that means vertically scaling it, and always vertically scaling will always have a little limitation, correct? And the same thing happens if the high traffic based application. So let's say your database server has a lot of traffic in it, and then because of the fact that everything data is being served from a central location, the high traffic write and read will be impacted because there is a lot of data, but your single centralized database servers keep on serving the particular data. And then also think about the backup perspective. For example, your backup will be very difficult, right? Because you have a large database of users, and also you will have to, in order to maintain high availability, you will have to put in a lot of efforts, right? So those are the problems that you will face, correct, as part of your database. Now the solution, what is the solution? Let's go back and understand here. So let's say today you have this big machine, right? And then you have your users accessing it from here, user accessing from here, etc. So when I say user, that means your app, right? It's accessing from here, here and here, right? A lot of users actually. Now, but you have a centralized database which kind of try to serve everybody, right, over the globe. Now there will be a lot of impact, right? As I said, we already mentioned that there will be performance impact. You cannot scale it well. There will be some issues with the maintaining the high availability, maintaining the backups as well. So what will be the solution of it? What could be the solution of this approach, right? The basic solution would be, what you do is, let's say you have traffic here, you have traffic here, you have traffic here. So what you will do, instead of having a big machine, you will have machines here at 3 different regions, right? So these guys will query here, these guys will query here, and these guys will query here, right? So this way, you see, these are doing queries here. So this way, you don't have a big machine, right? You don't have a big machine. All your users are being served by their respective machines that they have. So these machines that you have, first of all, it's a kind of architecture, right? What architecture it is? It's shared nothing architecture. Nothing is being shared, right? So your database sharding is based on architecture of shared nothing architecture, right? So this is one point. Second point is you have multiple machines rather than having one centralized machine which is serving all your data and you are facing issues with. You have one single machine, and that machine that you will call this machine as your shard, right? All these machines you will call as shard. You will call this as shard, right? So this is your sharding. So what you did is you have broken down your big machine into smaller machines. So in a way, so your queries from your users, it could be anything. Maybe your users are distributed worldwide, geographically. Your users might be distributed in some other way, let's say. But the point is you are trying to separate and distribute the data among different machines, right? So if you see, what happens is you basically distributed the data, the big data, into you broken down the data, distributed the data into 3 several machines, right? So this concept is known as your sharding, right? And each of this machine will be known as shard, and this whole architecture is based on shared nothing architecture. That means none of the shard is sharing anything with each other, right? So it's a big DB has been broken down into shard 1, shard 2 and shard 3, right? So that's the concept of sharding. So let's go back to the newsletter and understand. So as I already explained you, right, the basic possible solution of sharding comes where you divide the big database, distribute the database into several machines, and your each client can access, it could be anything, can access the data from each of the respective machines. So all of these issues can go away. Your geographical user maybe can, can faster the query. So let's say if you go back and understand, let's say this particular user, you have your server in country India, right? And then you have one server, let's say, in Malaysia, and then you have one server for, let's say, your Sri Lanka, right? So you don't have to keep your database in one single location. For example, in India, where your data will be served. Rather, you have one database server in each of the country, and which will be known as shard, and then all the traffic that belongs to India users will go to this particular shard, and then this particular Malaysia customer will go to this particular shard, and all the Sri Lankan customer will go to this particular shard. So you have divided the data based on country, based on geographical location. So these are sharding techniques that we will talk about it. But the point is, you see, you have kind of enhanced the performance, right, in adding the technique in between of sharding. So now, as I said that we have broken down and distributed the data, right? So the database sharding is also storing large database across multiple machines. All right. Now we will have to understand, there are certain, we understood that, okay, what is sharding? What are the problems if we don't use sharding, what could be the problems, right? And that only happens at a bigger level. It's not like that you will do the database sharding. It's basically part of database partitioning. You have horizontal and then the vertical partitioning. But I would say partitioning is a different topic. We will cover that in a different lecture. So there are now certain techniques using which you can implement sharding in your architecture. So first is your range-based sharding. So what it says is, let's say you have a data. So there is a concept of partition key. So partition key defines on which basis, on which key, what will be the key parameter on which we will define the partition. That is your partition key. It is also known as your sharding key. All right. So let's say you have a big database here, right? Now in this particular big database, you have 1, 2, 3, 4, 5 entries. Now you have pin code, date join, name and city. So here I'm saying that my sharding key, the partition key, or the column on which my partition or sharding will be done will be ID, this particular ID field, right? So now, instead of keeping all records in one centralized database, what I did is I distributed the data into 2 different shards. I say each shard will have data within a range of ID. So I say my data in sharding, a shard 1 will have a range starting from 1 to 15, and the second one will have ID range from 15 to 30. So each query which is associated, so for example, now there is a read query for ID 13, right? So that will go to your shard 1 because of the fact that this particular shard 1 has this data, right? So your sharding key, understood the sharding key, and then we understood the partition key, and we understood the range. So range is you are distributing the data based on a range, and then that particular range will be defined by a partition key. It is also known as sharding key. So it's very straightforward, right? Now move on to your hash based sharding. Now how your hash based sharding works, again you have the same data, let's say, and your sharding key, let's say again the ID field. Now how will you find out in which shard your data is? Now the problem statement on which shard your data is. How you are figuring is, if you are aware of the implementation of hash map, right? Your hash map, what it has key and value, right? If you remember, your hash map has key and value. So in the key and value, what happens is you have your buckets, right? You have your keys and these has your buckets. So what happens is this is your buckets and this is your keys, right? So this is, let's say, K1, this is, let's say, K2, this is, let's say, K3. Now these are bucket. The bucket has your data. In order to find out that where you have stored the K1 data, or the problem is if you are appending K1, where will you store that K1 data will be defined by a hash function, will be a function which will be known as hash function. So here in between you have a hash function. So K1 the hash function will be applied at K1, and then it will basically calculate something, and then this will say, okay, in bucket 5 you have the data, and bucket 2 you have the bucket 7 you have the data. And it's same for K1. K2 it applies that you have the data to B0, right? So K1 has data in B5 and K2 has data in B0, so that a particular outcome is being calculated by a hash value, right? So how do you get a generated hash value? By applying a hash function. So same way your sharding, this hash based sharding works. What you do is, on your sharding key, on your partitioning key where you have ID here, you apply a hash function, and then you understand, okay, and then the generated hash value, you have a hash function in a way that it will always generate a value within the range of your sharding, right? So now hash function says, okay, 13, when you apply hash function, it says 1, so it will reroute your query to your shard 1. So that's how all your queries are being rerouted to your respective shard. Now you might have a question, okay, you are saying that all this rerouting will happen, but where will this rerouting happens? So this is again a challenge of database sharding comes with. And what is that particular challenge? If you are implementing sharding, so if you see your sharding is being accessed by whom? If you see these guys are your accessing your sharding. These guys are nothing but your client, right? So if you have a mobile phone here, your mobile phone is being accessed by a server, right? So this is nothing but a consumer. So the problem of database sharding, a challenge is the consumer should be sharding aware, right? It should be sharding aware. You might be using some kind of library, some kind of software implementation here. So it must use a library or something which will aware this particular client to understand the concept of sharding and to calculate the targeted shard, right? This is one way. Second way, you basically introduce a load balancer in between, which will basically do the calculation and understanding of sharding on the behalf of this client, right? So there could be one or two way, right? This is where your calculation of all these things will happen. Now in the hash based sharding, I just said in the partition key there will be a hash function applied and there will be a generated hash value. This generated hash value will basically define a particular shard. Now you see, in problem 1, in the range based sharding, we basically had an issue. What issue was that? Let's quickly understand that in the range, let's say in your database, you have a range, let's say 500, right? And then you created, let's say, 2 shard. One shard has the range 1 to 50 and second have 151 to 500. Now let's say later on this distribution happens. Now later on what happens is there are a lot of keys, lot of data which had an ID between 1 to 250 got deleted, right? So you see this still has more data, this has less data, so it's not equal distribution of keys, right? So that's the problem, because there is no way to understand that. So this is where your hash function solves that problem. So if you use hash function solves a problem of even distribution. Because of the fact you are applying hash function, your data is distributed evenly. So it's kind of a good approach to implement sharding, right? One of the good approach, I wouldn't say the best approach. Okay, and then you could have a problem with hash based sharding as well. So there are trade-offs, right? It's nothing like good and bad approach, I would say. There are trade-offs. So I said, what could be the problem with hash based sharding? You see, if you are using a hash function which is based on the number of shards, now what could happen tomorrow if you remove one shard or one shard is down? You will always end up having your data, your query will be rerouted to incorrect, right? Incorrect shard, right? Maybe your the shard today, yesterday the shard you had, you don't have it anymore. So if you have any hash function which is dependent on your number of shard, that could lead to be a problem, right? Could be a bottleneck. So again, that's a trade-off. So again, that depends on what kind of hash function you use, right? Then you have the last, not the last, actually I would say second last, the directory based sharding. It's very simple. It's you have again the data, you see you have the data, right? And the data, you have your partition key, and then you maintain a lookup table. And then you simply, what you do is you simply have to see that for this particular key, this particular partition key, which shard I have the data in, right? So it's kind of acting as an index for you. So for 15, I would say 15 is the data for 15 presents in shard 2. It will, for example, rewrite it your query to shard 2. So that's how your query will work as part of your lookup table. Now the good part of this approach, right, is as I said, if you are using any hash function which is depend on the number of shards, it could lead to a problem, right? But directory based sharding, it's not the problem, right? Because you don't have to it's not dependent on the number of shards. Second thing, but this is again comes with another challenge. You see, every time you are adding an entry into this record, you will also have to maintain the same record in the lookup table, right? So again, you see, you have various sharding techniques, but again you have different trade-offs. So it depends which trade-off aligns with your requirement, respectively you will have to select, right? And the last one, we have the geographical based. As I already told you in the beginning, for example, you could have a shard based on a country, so all that traffic which is coming from that particular country can be rerouted to that particular shard. So that way your query and everything latency will be improved, right? So this is your geographical sharding. So you have 4 types of sharding: one range based, hash based, directory based, and graphical. So again, as I said, there is nothing better and nothing good. Everything is trade-off, depends which trade-off aligns with your requirement, right? And then let's quickly understand that what are the problems that database sharding have. If you introduce database sharding, don't think it's very easy to maintain the overall system, right? Your enterprise does that, but in my opinion, the only enterprise can does that which has a very large scale engineering team and a very large scale engineering team, right, where you can manage multiple things, right, because it comes with a lot of effort. So you see, first of all, because if you are maintaining database one place, it's very easy. It's not easy, although it will be complex, but at least not complex as maintaining the shard, right? So as I said, maintaining complexity in implementation and maintenance. As I said, that developers need to handle the logic for distributing data across shard, right? We basically had a look at 2 different approaches. How can we access the shard? Now there are different data distribution challenges, as I have been talking about For example, the main problem with maybe your one shard is overloaded with a lot of keys and another shard is not overloaded, and it has the less data. So that's the problem of data distribution. The goal of sharding should be that each of your shard, the database servers, should have the even distribution of your keys, right? Otherwise what will happen is you may end up having a lot of overloaded a lot of data into one, and which will basically degrade the performance of application running in that particular region, right? Or whatever data queries to coming to that particular shard will have a performance impact. Then there will be rebalancing shard. For example, let's say some data goes away, some data also added, so those things needs to be balanced, right? So this is where rebalancing needs to come. As I said in the middle of lecture, that your one shard can have being overloaded with a lot of data, other did not, so you will have to rebalance. Engineering team has to come up with a strategy so you can rebalance everything correctly, the data correctly across all the shards, right? Another problem that comes, which is very famous, right? The problem of cross join. So it's not very easy to perform join operation across multiple shards, right? So let's say you have you need certain kind of data from two different places, right? So you basically have to get that particular data from two different places, two different shards, right? For a set of data, then you will have to query multiple shards. Then that particular operation will be difficult to implement, right? It won't be very easy to implement. Now how can we do that? The way of doing so is maybe you don't have to call from the server two different shards. As a client for two different shards, your server may call two different server, and then at the business logic level you are performing the join operation. And any strategy, any efficient strategy you could come in, but the point is maintaining the cross join across different shards, maintaining the transactions, is not very easy. And then you have schema changes. As I said, that if your same data is present, same schema is present across multiple shards, then you will have to make sure that the schema is same. If you are releasing some change, migrating some change to your schema, you will have to make sure the same change happens over everywhere. Again, that's add-on capacity, it's adding a more complexity, right? And then, as I said, the last one, the application level, shard awareness, right? So developer has to use some kind of library. Your application needs to understand the sharding is being used, and the shard pickup and all those things should your client has to do, right? So this was all about sharding, guys. We understood what is the problem that sharding solves, right? And then what is sharding and how can we achieve sharding using these different techniques. We understood the range based, hash based, directory based, and the geographical sharding. We also understood what are the problems in sharding. We also understood that sharding is not very easy to understand. It's not for everybody, unless to reach to a point that there is no solution exists without database sharding, right? So now this is my newsletter. You can go to suchet.substack.com where you will find this document. And then you can relate to this lecture, right? If you really like my content, you can follow me on LinkedIn, you can subscribe to my Substack, and then you can subscribe to my YouTube as well. So far we covered database sharding. In next video we'll cover something else. So thank you so much, guys.